So today we're going to go over some compound growth word problems and exponential decay and growth problems and maybe a continuous one. So how do we know which model to use? Should we use an exponential growth model? Should we use an exponential decay model? Or should we use a compound model? Well, you want to look and read carefully, and you want to look for that word compound. So since it's compounded, that means we're going to use this model. So we're going to use y equals. And usually in business, they use P instead of A. It doesn't really matter. P is the initial amount. So it's called the principal. A is the initial amount as well. So I'm just going to put a P there because the business world, they'll usually use P for principal. And what are we initially putting in? So our P is $3,000. Our rate is, our R is 4.25%, but we need to change that to its decimal friends, so we need to move that twice back. So we're actually going to punch in 0.0425 for the R. And then we are compounding it quarterly. So if we're compounding it quarterly, that means my N is going to be 4. If we compounded it monthly, N would be 12. If we compounded it daily, N would be 365. If we did biannually, it would be 2. And if it was annually, it would be 1. So in this particular problem, it's being compounded quarterly. So N is 4. And how long do they want us to keep this money in? They want us to keep it in for 6 years. So our T is 6. And we're just going to plug and chug. So 3,000 and 1 plus 0.045. Got to make sure you have that decimal in the right spot. It's a quarterly, and so it's quarterly, and we're putting it in for 6 years. And then we're just going to type in this into our calculator. So just, you need to learn how to type in the whole thing at once, because that way you'll get a precise amount. So I'm just going to do 4 times 6, actually. I'm going to do 4 times 6 and say 24. It makes it a little bit easier to plug that in correctly into your calculator. So let's see what you get. Why don't you go get a calculator? Go get a calculator, pause the tape, punch this in. Let's see what you get. So I got $3,866.18. You should always round to the nearest penny. You should always put a comma after the 3 digits, and you should always use a dollar sign when you're talking about money. So what happened in this story? So out of that, $3,000 was my own money, right? So that means if you subtract $3,000, obviously, what's left over is your earned interest, or your interest earned. So that is called your interest, and that's what you earned by leaving your money in that product, that Roth IRA, for 6 years. You actually made a profit of $866.18. Of course, the government's going to come and take a little chunk away, right? But anyways, you're still earning money. Now, what's important is that some kids will round and they'll do what's inside, right? So they'll do this part. And if you do that part in green on your calculator, you get this decimal. You get 3,000, and then let me see what it is. So what you get is this really, really long decimal. So sometimes kids don't want to write out the whole decimal, so they'll just abbreviate, or I should say round, and they'll just say 1.01 to the 24th power. And you might say, well, is that okay? Well, if you actually punch this dollar amount or that expression into your calculator, you get 3,809.20. Look at the difference. So this person basically rounded the growth factor. So remember, this is your growth factor, right? So they took their growth factor and they actually rounded it to 1.01. And so because they didn't use this whole entire part of the decimal, they actually didn't get as much money back. So it's almost $60 difference. So that's why when you're punching into your calculator, you want to punch it in all at once so that you can get a precise amount. Now you can emphasize if you wanted to. You can say it's an approximately. So the model's approximately 3,000, 1.01 to the 24th power. But that's an approximate value because you rounded, right? But you don't want to actually use that. You want to be able to punch in the exact amount so that you can get a precise, exact answer. Okay? So now we have this scenario. 3 people were initially infected by a virus. Each person had to infect 4 people each day to stay alive. Write an exponential model, then find how many people are infected on day 8. So there's nowhere in there where it says the word compound. So because it doesn't say compound, we're not using this formula. So then we have to decide whether it's an exponential growth or an exponential decay. So each day, are we getting more people infected or less people infected? So aren't we getting more people infected? So therefore, we're going to use the exponential growth model, which says y equals a 1 plus r to the t. So our a in this problem is our initial amount. So we started with 3 people initially. Our infection rate is 4 people per day. So our rate of infection is 4 people per day. And our time is, we're looking at day 8. So therefore, it's y equals 3 people were initially infected, 1 plus your r. Should probably clean this up a little bit. It looks a little sloppy. And the r was 4 people per day, and the time is 8. So that means our model, well, our model really is 5 to the x t power, right? That's called your model. So I've been trying to express when we're talking about a model that represents the story, that a model should always have 2 variables because there's a relationship going on, right? And that relationship is we have time going on, or in this case, the time is days, and then y is the people infected, right? So x is the number of days and people infected. And so we can say on day 0, 3 times 5 to the 0 power would be 3 times 1. So there's 3 people initially infected, which we knew, right? On day 1, we could plug in to that model 3 times 5 to the first power, and that would give us 3 times 5, which would be 15, and so on and so forth. So we could jump down to day 8, and we could say, well, what happens on day 8? That would be y equals 3 times 5 to day 8. So let's grab a calculator for that. That looks kind of big. So that came out on day 8. That's a high infection rate. 1,171,875 people are infected by day 8. Remember that the base is called the growth factor. And the growth factor is what you can multiply to get to the next day. So we could have just went 2 times 5 and then 15 times 5. So 15 times 5 is 50 and 20. So that's 75. And then we could do 75 times 5, etc. And so remember, that's your growth factor. So we want you to know the pattern of a growth factor. And then remember, the growth factor is equal to 1 plus r. So this is your growth factor. So the growth factor is your base. So we want you to see this. The growth factor is your base, and the growth factor is equal to 1 plus whatever the rate is. So what if I gave you y equals 5, 6 to the t power, and I said, what is your rate? What is the rate of infection? It's not 6. 6 is your growth factor. So remember, 6 is what you're multiplying by. So on day 0, you're going to have initially 5 people, and then you're going to multiply by 6. So that's your growth factor, is what you're going to multiply by. And so how do you figure out what your growth rate of infection is? Well, remember, the growth factor is equal to 1 plus r, And so the growth rate in this problem is 6. So 1 plus what equals 6? Well, so therefore rate would have to be 5. So in this particular problem, the rate of infection would be that they would have to infect 5 people per day to stay alive, right? So good information just to kind of know. So let's try a different problem. John deposited $2,500 into an account for 5 years at an annual rate of 3% that compounded continuously. What is the interest earned on the account? So there's that word compounded. And it's not compounded monthly, it's not compounded quarterly, it's not compounded daily or annually, it's compounded continuously. So therefore we have to use this formula. So the compound continuous formula is A equals PE to the RT. So the P in this problem is what you initially started with. We put in $2,500. The E is, that is an irrational number, and E is approximately 2.718, but we don't want you to use the approximate number. We want you to know where the E key is, and if you go find your natural log key, it is hiding underneath that key, so you're going to have to hit your second key to get to the E key. So we want you to know how to punch that in, right? So our R in this problem is 3%, right? So our R is 3, and therefore we got to move the decimal twice back to the left. So we got to put a placeholder there. So 0.03 is our decimal, and the time is 5 years. So we're going to keep it in there for 5 years. So when we put that in, that's $2,500 compounded continuously. So it's E to the 0.03 times what? Times 5. So when you type that into your calculator, I would type in 2,500. I would hit my times key. I would hit my second key and my E to the X key. And on my calculator, it slaps a parentheses there. So I'm going to type in 0.03. I'm going to hit my times key. And then I'm going to type in 5. And then you got to end the parentheses. So I'm not going to use the parentheses for multiplication. I'm going to use the times for multiplication. And if your calculator does not put a parentheses there, you must put a parentheses around where the exponent was. So you're going to need to put a parentheses around where the exponent was in the front and the back, or you're not going to get a right answer. So pause it, check out your calculator skills. So this is what I got. So we always want to round to the nearest penny. So remember, you look at the next digit, and if that digit is 5 or bigger, that means we're going to bump this up to 9. So our actual amount is $2,904.59. But that wasn't the question. The question was, what was the interest earned? So remember, we put up $2,500 of our own money into the account. So we got to subtract that out to see what was our actual earned interest. So the interest that we earned on that account was $404.59. So make sure you're reading the problems and making sure that you're answering the total. So this was the total amount that we got at the end of 5 years. And this was the amount of money we earned off of that account, which is called the interest earned. Maybe one more? Okay, here's the last one. A tractor originally cost $32,000. If the tractor depreciated exponentially at a rate of 5% annually, how much is the tractor worth at the end of 8 years? So I don't see the word compound in there at all. So we're not using any of these at all. So we're going to either use an exponential growth function or we're going to use an exponential decay function. So is the value of the tractor getting to have more of a value or less of a value? So the word depreciate means that it's going down. So each year it's getting worth less, right? It's depreciating, it's getting worth less. When you buy a new car, as soon as you drive it off the market, it's going to devalue in its price. So we're going to use the exponential decay model. So the exponential decay model, since it is getting less and less and less, is y equals the initial amount and then 1 minus r this time to the t. So the initial amount is $32,000 because that was the original amount of what the tractor cost. The rate of depreciation was 5% annually. So we got to convert that to 0.05. And we want to see how much it's going to be worth in 8 years. So our model would be y equals 32,000. 1 minus 0.05 to the t. And when you're doing a model, it's always important to simplify that model. So this is called a model again. I just want to reiterate what a model is. A model should have both variables. So we want to be generic, right? So we don't want to put the 8 in there if we want to know the model. So sometimes they'll say write a model and then tell us how much there's going to be in 8 years. So the model has to have both a y and an x, or two variables. So in 1 year, what's the tractor worth now? In 2 years, now what is the tractor worth? In 3 years, what is the tractor worth? And remember, this is called your decay factor. So that is your decay factor. And if we were doing a table, we know that initially it was $32,000. And in 1 year, in 2 years, 3 years, 4 years, we could just multiply this by 0.95 to get the next years and what it's worth each time for the next year, right? And that's called your decay factor. So the base is always called your decay factor when it's going down and getting less and less. So then we don't need to use a t-table. That's what's nice about a model, is we can jump and say, what's happening at year 10 or year 20 or year 50 or year 8. And they wanted to know about year 8. And then let's zippity-do on our calculator and let's see what the tractor's worth on year 8. So by year 8, the tractor now is only worth $21,229.45. So let's see how much we lost. So the tractor was originally $32,000 when it was new. And then 8 years, it was only worth $21,299.45. Let's see how much money was lost from that tractor in 8 years. They didn't really ask about that, but let's look. So in 8 years, the tractor lost a value of $10,755, according to this story. But what did they ask us? They asked us, how much is the tractor worth in 8 years? It is worth approximately $21,000 in 8 years. So the person could sell it for approximately that much money. All right, have a good day.